Good evening. I expect that this scene looks rather strange to you. It's a new design study of a manned base on the moon, and even though it may look like something out of science fiction, it is something that will probably be set up before the end of this century. Now, of course, there are different ideas about moon bases, and it's been suggested that the Russians, at least, have given up the idea of manned trips to the moon for the moment. Well, that may or may not be so, but certainly the Americans haven't given up the idea. And in any case, although artificial unmanned probes will be immensely useful scientifically, I personally haven't much doubt that the first man will set foot on the moon within the foreseeable future. That being so, clearly we want to find out just as much about the moon as we possibly can. And in particular, we want to find out whether the moon's surface is going to be safe for a rocket to land. Now, here again, there are two definite schools of thought. Anybody who looks at the moon through even a small telescope can see the mountains and the craters and the valleys, and of course it is a superb sight. But there are no local colors on the moon. You don't get reds and blues and greens. Everything seems to be the same kind of uniform yellowish grey, and it's been suggested from that the entire moon is covered over with a layer of dust or ash. And that being so, naturally we want to find out how thick the dust is. Now, according to one theory, which was due to Dr. Gold, formerly of Greenwich Observatory, the so-called seas of the moon, which are great dry plains, are in fact tremendous dust drifts, kilometers deep, so that any rocket landing there will simply sink out of sight into an ocean of dust. And after a long and dangerous voyage through space, I think that would be most disappointing. However, not very many astronomers follow this idea, I think, and the general consensus of opinion is that although there may well be a lot of dust and ash on the moon, the surface layer isn't likely to be more than, well, 2 or 3 inches deep, which means, of course, that it will be safe for a rocket landing. On the other hand, we can't be too sure about it, and there may easily be unsafe areas here and there. Well, just using telescopes alone, it's a bit difficult to find out, and I think really research with unmanned probes is the only way to find the answer, and the program of that kind is underway now. Secondly, when we are considering bases on the moon, we've got to make up our minds where they're likely to be. And to start with, we know that the temperature conditions on the moon are extremely unpleasant, because the moon has virtually no atmosphere. There may be a trace of air left there, but it's so little that to most intents and purposes we can forget about it. And that means, of course, that there's nothing to shield the moon's surface from the rays of the sun. So on the equator, at lunar midday, the temperature can go up to something over 200 degrees, whereas in the middle of lunar night, it goes down to 250 degrees of frost. And in fact, there have been some very recent measures which indicate that the temperature may be even lower than this. Now, we certainly can't escape the cold of lunar night, because since the moon has no air, then the temperature at night time is the same over the whole world. On the other hand, we can avoid the intense daytime heat if we don't land near the equator. So we've got to look for somewhere comparatively flat and some way away from the moon's equator. And the place that seems to fill the bill best is the great dark plain known as the Mare Imbrium, or the Sea of Showers, which is covering most of the picture on the screen now. Incidentally, just to give you an idea of the scale, look at that dark-floored crater, Plato, which you can see at the end of the pointer. Now, that is one of the typical lunar circular formations, and its diameter is 60 miles, so you can see it really is a large thing. And then way over to the right-hand side of the picture, there is another crater, Archimedes, which isn't very much smaller than Plato. And it's just near Archimedes that the Russians consider that their unmanned rocket, Lunik 2, crashed on the moon in September 1959. Now, I say crashed because, of course, it did literally crash. It came down with tremendous velocity, and it undoubtedly destroyed itself. And I often wonder whether lunar explorers of the future are going to find the remains. I rather suspect that they are. The next step, I imagine, is a so-called soft landing, when you bring down a vehicle on the moon gently enough to avoid breaking its instruments. That may have been tried. I'm thinking, of course, of the last Russian rocket, Lunik 4, which simply went past the moon, but I think was probably designed to land there. That was one of the less successful Russian probes. But following that, I've no doubt that manned flight to the moon will be achieved. And that brings us on to the question again of moon bases. Now, I'm talking about moon bases tonight for two reasons. First, because they are very topical, and we've just shown you one new design study. But secondly, because I am delighted to have with me my old friend, Arthur Clarke. Now, Arthur, you, of course, were forecasting developments of this kind, more than 20 years ago. And Arthur Clarke is known to everybody as one of the pioneer space research thinkers in this country. But particularly, I think, you've been honored for your pioneer work in suggesting the communication satellite, which was purely your idea, and of course has now been brought to a brilliant conclusion. So I think my best policy now is to hand over to you and ask you to say something about what has gone on in the past and what you think is going to happen in the immediate future.
Well, thank you, Pat, and I'd like to begin with a flashback to the communication satellite which you mentioned by showing this illustration, which is of some sentimental interest to me, because I displayed this on BBC TV about 10 years ago, and this was undoubtedly the first time that anything about communication satellites appeared on TV anywhere in the world. This was an illustration made from one of my early books of the communication satellite network, which I envisaged in my original paper back in 1945. 3 satellites equally spaced around the Earth at such a height that they would take just 24 hours to make one revolution in their orbits. And because of this, you see, they would stay fixed over the same spot on the Earth. So only 3 satellites could provide a global television or radio service to the whole planet. Now, this so-called synchronous or stationary satellite has just been achieved by the Americans with the launching of the SYNCOM satellite a few weeks ago. And I think that this is going to be a tremendously important thing, and the equatorial stationary satellites are probably the key to the future of world communications. Another flashback to what I call the Victorian age of space flight, or the pre-Sputnik era, is this illustration, which is also about 12 years old. This was made by my old friend Rafe Smith, who was one of the pioneers of space flight thinking in this country. And it shows a space probe, a robot space explorer, passing by Mars, just as the Russian space probe did recently, although unfortunately that didn't work. And of course the American space probe, Mariner 2, did flash by Venus a few months ago and do just the sort of thing shown in this picture. However, we are already supposed to be talking about the moon tonight. So back to the moon let us go with this picture of one of the pre-war designs of the British Interplanetary Society, which I also showed on TV a good 10 years ago, of a ship to carry 3 men to the moon. And this is the part that would land on the moon, and you see the shock-absorbing undercarriage on which it would set down and then take off again back to Earth. And this concept is quite strikingly like the vehicles now being designed, now being built in America to take the first American explorers to the moon as part of Project Apollo. This scene is a little later in the stage when we have not 1 but 2 moon ships there. You see one landing in the distance. I don't think they have chosen a very sensible landing site, but that is a little artistic license. And this sort of scene of men beginning to explore the moon is something from the fairly near future. However, beyond that, we come to the more interesting and exciting stage of actually setting up a permanent installation there, a lunar base. This is going to be a tremendous engineering project. And this is a concept which Rafe Smith worked out, I think, around about 1948, of a lunar base. And there's quite a lot going on here. I'll just give a quick run over the picture. In the center, you see the pressure domes inside which the inhabitants, the lunar colonists, you might call them, will live. There's air inside those domes at normal pressure, so they can live ordinary lives. The only thing abnormal, anything strange inside those domes would be the low gravity, because on the moon, gravity is 1/6 of the Earth's value. So a 180-pound man would weigh only 30 pounds, something which I think may be very advantageous and possibly quite good fun. Around the base of these domes you see a series of tubes, large tubes. Well, that, believe it or not, is a farm, a lunar farm. Now, it may sound very fantastic to talk about farming on the moon, but if a lunar base is to be set up as a permanent thing, it must be self-sustaining. That means it must produce its own oxygen, water, and food. We can't ship these things from Earth. The expense would be prohibitive. So therefore, one of the problems of the lunar colonists is to find the raw materials of life, particularly oxygen and water, and then grow food from lunar materials.
You know, I think it'd be interesting to compare Rafe Smith's drawing of so many years ago with this new design study that's just been put forward by the Americans, because there's a great deal of similarity there.
Yes, well, this is inevitable because engineers dealing with any particular problem have to think along the same lines. And all these lunar base projects do have domes, pressure domes like this. And the only point of disagreement, if you can call it that, is whether or not these domes should be above or below the surface.
Well, I think a great deal has depended there upon the question of the lunar atmosphere, because if the moon had proved to have anything of an atmosphere, then of course the surface dome would have been the answer. But since we now know that the moon's atmosphere can, to all intents and purposes, be neglected, do you think that this means that the lunar base has got to go underground?
Well, if it turns out that a meteor bombardment is a serious danger, then undoubtedly we will have to put our bases underground. But I rather hope that the necessity of a lunar underground movement does not arise. I hope we can stay on the surface and look at the stars.
So do I. There's one question I'd like to put here. We've been talking about manned lunar bases, but I suppose the unmanned lunar base is bound to come first, the fully instrumented automatic station. Do you consider now that having a man on the moon is going to be a major advance from a scientific point of view?
Undoubtedly, because instruments can only look for what the things they are told to look for. They cannot discover, analyze, report the unexpected. This has been proved over and over again in space. Moreover, automatic space probes, sooner or later, and usually sooner, go wrong. And you had many times the example of a satellite which has cost millions of pounds to build and launch, going out of action because there wasn't a man with a screwdriver to make some trivial adjustment or to replace a tuppenny halfpenny resistor or condenser that had burned out. Ultimately, you have to have a man on the job to maintain the equipment and to discover new things and to consider new types of observation.
Yes, I see that, and I think it's a very valid point indeed. Now, another point that you made a very long time ago was the question of using the moon as an observatory and a physical laboratory. Now, have you got anything new to add to what you said then?
Not in principle, but I think the moon is going to be of tremendous importance as a base for scientific observations of many types. Because on the moon we have peculiar conditions which we'll be able to exploit, as we have always on this Earth exploited novel surroundings. We have low gravity, and we have no atmosphere, and this is going to be of tremendous importance to the astronomer in particular. Here on this Earth, the optical astronomer has always been severely handicapped by the fog and murk of the atmosphere through which he peers at the heavens. Even the radio astronomer is also limited on the Earth, because here there's mounting interference from electronic devices of all kinds. Moreover, he cannot build the really giant radio telescopes he would like to have, because Earth's gravity makes it an engineering impossibility. But on the moon, and particularly on the far side of the moon, shielded from the electronic racket of the Earth by 2,000 miles of rock, there's an ideal site for radio astronomy telescopes. And I think that in a few generations, almost all serious astronomy will be conducted either on the moon or in space.
Well, let's turn now, shall we, to yet another of the pioneer ideas, and that is the concept of using the moon as a kind of halfway house for voyages to the planets. I used to say Venus and Mars. I suppose now, since the Mariner 2 findings, we've got to say Mars and Venus, since Venus appears to be rather unwelcoming.
Yes, as a base for future explorations, further explorations, the moon is going to play a very important role in the future of astronautics. And I get rather annoyed with people who seem to regard the moon as the be-all and end-all of space travel. That's rather like asking the captain of the Queen Mary, well, why do you want to get to the Isle of Wight? The moon is just the first stepping stone on the way to planets which may be much more important. And also on the moon, we can try out various engineering techniques, constructing bases, for instance, like the one I just showed, which we will need to apply on other planets. On the moon, we are fairly near home, and if things go wrong, they can be put right more easily than on Mars or Venus.
True. What about the Martian base?
Well, of course, that's a good deal further away in time, but it will undoubtedly come. Here is a concept of a Mars base, which is, again, about 15 years old. It's slightly different from the lunar base I showed earlier. This time, the domes are transparent, and they're not rigid, they're not solid objects. They are really transparent balloons held up by the air pressure inside. So you must imagine that they are made of something like polythene. And there are several of them connected together on the principle of not putting all your eggs in one basket. If one of the domes is accidentally punctured, well, you can always retreat into the others. The nearer one is the residential area, and beyond that you see the farming areas again, and factory areas and so forth. And there are airlocks through which the inhabitants can go out and explore the surface of Mars, the fascinating little red planet.
Look, Arthur, some years ago, 20 years ago now, you made a series of forecasts. One of them, the communication satellite, has certainly been fully vindicated, and everything is going more or less as you expected, although I agree that it's gone more quickly. Well, you made those forecasts, and they've come basically true. I wonder now whether you'd like to make a few more forecasts and give us your present ideas as to what's going to happen in the immediate future, and we'll see then whether you're just as right again.
Well, for the immediate future, obviously men are going to fly around the moon in the quite near future. I'd say possibly in 5 years, certainly in 10. That's a flight around the moon without landing. It may even conceivably happen next year. The landing on the moon, which of course is the big thing, I think that I prefer to say it'll be around 1970. If you want to pin me down, I think it's possible that the Russians may succeed in doing what some of them have said they intend to do, which is to land on the moon on the 50th anniversary of the October Revolution, which is November 1968. I think they may well do it. I think it's very unlikely that the American moon project, which really is a colossal thing costing $10 million a day, will succeed in getting men to the moon and back, which is equally important, before 1970, but it will not be much after that.
What about the Martian base? Are you prepared to speculate as far as that?
Well, this is going further out on a limb. I think we will be around Mars, we'll be orbiting Mars without landing in 20 years, and perhaps within 25 there will be men on Mars. So the Martian base may just come in this century.
Well, thank you very much indeed, Arthur, and I, for one, shall be quite fascinated to know whether, in fact, you're as correct this time as you were in 1930, and 1930 to 1940, in the days when spaceflight was still regarded as something of a scientific joke. So there we have it. I think, though, one thing stands out very clearly indeed. That is that the space research program has gone forward much more quickly than even Arthur Clarke and the other pioneers believed that it could possibly do. Whether this progress is going to be maintained, well, of course, it's just too early to say. But whatever happens, I'm sure that the program will go on, and unless we find any entirely unexpected difficulties, then men will reach other worlds in the foreseeable future. And whatever's going to happen in the next few years, I'm sure, is going to be both fascinating and extremely important from all points of view, just as the old pioneers said that it would be. Good night.